Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Problem 139 references the previous problem, 138. It tells you that there are 13.62 grams of sucrose dissolved in 241 grams, milliliters of water, which yields a total of 250 milliliters. So problem 139 asks, given that information, what the boiling and freezing points of that solution are, and whether boiling that solution would take much more time than expected, and whether the solution would freeze in a typical freezer, which runs at about negative 18 degrees Celsius. So recall that the the formulas for figuring out the changes in boiling and freezing points for aqueous solutions are like this for non-electrolyte solutes, where you just have the molality of your solute multiplied by the freezing, or the boiling point constant for aqueous solutions. And then the freezing point is very much the same, molality times that freezing point constant. So for aqueous solutions, this K here for boiling is 0.512 degrees Celsius per molal. And then for the freezing point, it's 1.86. So the first thing that we have to do here is figure out the molality of this particular solution. And so what molality is, if you remember what you've read in your book, it's the number of moles of solute over the number of kilograms of solvent. So what we can do here is we can take the 13.62 grams of sucrose and convert that to moles by applying the molecular weight, which is 342.3 grams per mole. And then we can divide that by converting this 241.5 mils of water to grams using the density that we were given. And then we can convert to kilograms. So I know that 1 kilogram is equal to 1,000 grams, canceling all of those units here. And that gives us 0.0398 moles over 0.241 kilograms, or 0.165 molal. So all we have to do now then is plug this molality here back into these equations to figure out the freezing and boiling points of the solution. So we can do the boiling point first here. We can plug in the 0.165 molal and the boiling point constant for aqueous solutions. And that gives us 0.0845. So because what this equation tells you is the change from the boiling point of pure water, or the elevation of boiling point once solute is added to water, you add this to 100, which is the boiling point of pure water, giving us a boiling point of 100.0845 degrees Celsius. So this problem also asks whether boiling a solution would take much longer than just pure water. And if you look at how much different this is from 100 degrees, it really isn't that much, 0.08 degrees. So boiling the solution probably wouldn't take too much longer than pure water. Now we can figure out the freezing point, by doing the same thing, plugging in the molality that we solved over here, plugging in that constant, and that gives us 0.277 degrees Celsius, or a freezing point of negative 0.277 degrees Celsius. And so again, the problem asks us to tell whether or not the syrup would freeze in a standard freezer, which the problem points out is about negative 18 degrees Celsius. Since this freezing point is not that much, not very far from 0 degrees, which is the freezing point of pure water, yes, the solution would very likely freeze in a normal freezer.